I'm actually doing some designing here on Fusion 360. These PCBs, I have some coming in the mail in a week, but I have some work I needed to get done. And I was just kind of waiting for those PCBs to arrive, when actually I think I should get to work now. So let's hop right into what I'm doing. So Harry so gracefully taught me about how Fusion 360 works. I already created one component and then a component inside a component. So I'm going to select the XY plane and create. Oh, I'm already in a sketch. Sweet. So we're in a sketch. Let's go to the centered one. And this is going to be 30.5 tab 30, 30.5. But I kind of messed up already. First off, I need to make a parameter. So I went to modify and then change parameters. So I'm going to create some user parameters. So these are my variables, and this one is going to be PCB CELL0 7. It's actually just an increment of a mil, so that I know. It's 12 across. So that's enough parameters. So we're going to change this to PCB width. Enter twice. So those are fixed there. I need to make these so they're just the construction lines. Because I don't actually want to make a shape out of that, because I'm going to make the lines that I determine. Doesn't mirror. Let me see. I've never done mirror before, but I'm going to try it. So this is a normal line. I'm going to create a mirror. Objects. This. I'm going to clear it out. I want this object. Mirror line. Okay. So, oh, okay. It just does the same thing on the opposite side. Can I still move this? Yes, I can. Cool. All right. Same length, which is always going to be true. What am I talking about? That's always going to be true no matter where they're at because of the other constraint. So it doesn't need to be true. Okay. So I want to rotate this. The distance from here to here, I know, is the PCB diag divided by 2. So I'll just make it simple. And then I'm going to take these and I'm going to create a circular pattern. 2 selected. The center point is the center here, and then I want there to be 4. So that's going to go ahead and create, and I think also create these rules. And so it does. It's a fully defined rule that is met on all corners, and those are all filled in. And so we're in the habit of doing that. Let's just do the same thing here. There we go. That's the one I wanted. I know I'm doing it the hard way, but anyways, I'm going to create a pattern. It's going to be a circular pattern. Object selected, center point is the center point. I want 4. Hit OK. There we go. So that's the PCB width. So it's on both sides. This is the clevis pin cover. As you can see, there's not much room for these screw holes. But these actually need to be the width. One body. Yeah, it's the one body as a holder. Although it shouldn't just be one body because this is the top of the holder. But I guess this could be printed as is. I'm not sure. Because this thing might be wanted to be print sideways. But anyways, I think I'm just going to clip this together because it was pretty fun exercise. And just kind of wanted to show the progress that I'm making. on the open muscle project. So the PCBs come in a week, and right now I'm just going to be designing this portion of it, trying to get it so that way I can test the clevis pin holes, um, and see how well it does. Because these are wired well. These are like my testing boards. So I got a lot of these already, and so these can be arranged in pretty much any configuration. There's going to be wires up the wazoo, but I should make sure that I have decent scalability for this product. It's so easy to move on to the next one when I really need to hone some of the features of the ones that I have available to myself right now. But yeah, if you want to get involved, please contact me or please contact us. Like right now, it's just me working on this project. So I have to compartmentalize things, just to the different tasks that I have. But yeah, this is open source, filed under the Open GNU license. It's meant for humanity, for everyone for free. If anyone knows of a better license, that just make sure it gets to whomever needs it. The goal of this is to help people with their, if they have a prosthetic that they need to control, if they had an amputation of the hand specifically, but I hope it to be applied to any type of muscle groups or muscles that an apparatus could be made. Because these Hall effect sensors are inexpensive. The ADCs on most microcontrollers are sufficient enough to detect the signal, and to detect muscle contractions pretty accurately just using the Hall effect sensor and a spring and a clevis pin. So, until next time, thank you for watching. Hope you learned something. And if it was entertaining or whatever, just give it a like, subscribe, or share with your friends. Have a wonderful day. Turf Tax out.